Okay guys, hello and welcome back to the final part 3 of the software implementation for the timer. Sorry that these videos are so long, but there's a lot to explain with these timers because you got to calculate instructions and whatnot, so it's kind of involved. So anyway, what I've done is I've gone ahead and just hard set the reloads. Since we calculated everything based off that little thing that I made, I just hard set it at 61. I'm going to use the prescaler of 64. Whoops, I need to change my comment. Prescaler of 64. We're going to declare two global variables because when you go into an interrupt service routine, you're jumping out of main. So if you're messing with variables that need to go between the two functions, then you need to declare them as global. So we've got a global one of seconds. It's going to be our second counter, and we've got a reload counter that counts how many reloads of the timer. We've got you type for your ISR. You're going to say void interrupt, and you're going to declare timer 0 ISR. It does have to be this way. I did not make up timer 0 ISR for my function header. That is what you have to type in. So void interrupt timer 0 ISR. Similarly, I think you can do timer 1, timer 2, depending on how many timers you have. You can make different interrupt service routines for them. Anyway, in our interrupt service routine, this is wrong. I kind of copied and pasted some of this stuff. In this service routine, what we're going to do is we're going to check to see if... Oh, we don't need this. We're going to check to see if our reload counter is equal to the amount of reloads we want, because obviously if we're counting up every time we enter the service routine is going to be when it interrupts. So when it overflows, once it runs 256 ticks, it's going to jump wherever it is in main down here. It's going to jump to the service routine. And so when it does, it's going to then check, we're going to check our reload variable, which when we first fire this up is going to be 0, and we're going to check and see, is reload equal to our 61? Have we reached 1 second? If so, we'll add 1 to our seconds counter. Otherwise, we're just going to add 1 to reload, because that means that this is probably the first reload or whatever. We have to clear the interrupt flag. This is another one. This is another one that you want to make sure of. Is the TOIF is the timer 0 interrupt flag, is what that is. We have to clear it because it sets to 1, which flags it to then bring it to the service routine. So when it interrupts, it sets this flag to 1. So what we want to do is we want to reset it back to 0. That way the timer will continue. The timer will not restart once it overflows, as long as the interrupt flag is set to 0. So you have to make sure and set to 1. I apologize, set to 1. You have to make sure and reset it back to 0 so the timer starts counting again. So that's what you do there. Now you come down to main, and what I've done is I've declared a couple of variables. I'll tell you what they're for here in a minute, but first of all we're going to have to initialize timer 0, and here's where we pick the prescaler. Remember when we looked back, let's see, do I have it? Wrong one. There we go. When we have it, here's our layout. We have bit 0, 0 to 2, so you got 0, 1, and 2 is the actual prescaler. Then bit 3 is the assignment tool. So progressor assigns to timer 0 module or to the watchdog. Ours will be 0 because we want to assign it to timer 0. And then the fourth one, we're going to leave it as 0, and then internal instruction cycle clock, we want the internal clock, so we'll leave that 0. Interrupt falling edge of pin 2, that's what I wanted to choose. You can have it interrupt on the rising edge or falling edge of that clock. You can leave it as 0 because you can leave it as 0 because we can do it on the falling edge. That's fine. You can maybe get a little more accuracy if you play with your edges. Port A pull-ups are enabled by individual port latch values. That's fine. We can leave that 0. So if there's any pull-ups that we're doing, it's fine. So that's basically what we got. So essentially we're going to have from right to left, bit 0 to, I remember at least everything's backwards in this. So right to left, we're going to have a for our 64 a 1 0 1 and then 0 0 0 0 0 and all zeros. So if we go back to our code, that is exactly what we have: 1 0 1 and then 0, and then the rest will be zeros. And so that prescale, it sets the prescale for 64. What we're doing also by the TOCS is we're setting the internal clock. We're selecting internal clock, and we're also enabling the timer interrupts. T0IE is interrupt enable, is what that stands for. So we're enabling it, and we're also enabling global interrupts, because you have to have timer interrupts, which means it allows the code to interrupt and go to the ISR during that, and we're also enabling global interrupts, which these global interrupts are for the processor. The processor will have a register for interrupts, and that'll be a global interrupt, so you want to enable those as well. Then what we're doing is we're going to check, we're going to do seconds. We're going to mod it by 4, so that way we're checking every 4 seconds. So whenever our seconds turns to 4, we're going to do this, and we have to make sure, we want to make sure our pre-trigger, because remember this thing, the instruction cycles are moving way faster than a second. They're moving at what would we calculate to? 256 microseconds is how fast the instructions are moving. So what's going to happen if you don't kind of basically watch for the next one, you're going to roll through this 2 or 3 times, and so what's going to happen is you're going to go, if it's 4 seconds, do this. Well, then the next time it comes around, it's still going to be 4 seconds, because only 256, well, a certain amount of microseconds, but it'll still only be in microseconds because this code is not very long. Only so many microseconds will have passed, but it'll still technically be 4 seconds. So you want to put in like a pre-trigger variable, something that can count and you can check against what the seconds is. So as long as pre-trigger is not equal to seconds, basically seconds has been updated, it is now 5 seconds, not 4, and we say pre-trigger is, oh, and I forgot to put our pre-trigger in. We need to say pre-trigger is equal to seconds at that point. And see what that'll do is, as it comes through here, it's going to, we could even put this here, we'll put this at the top, put it up here at the top. Okay, so we put that up at the top, and what we're going to do is we're basically going to take and we're make a toggle variable, basically a variable that every time we enter into this, it's going to flip from 0 to 1, 0 to 1, because we're XORing it. So 0 1 0 1 0 1 0 1 every time we roll through 0 1 0 1 0 1, but it'll only roll through every 4 seconds. So what we'll do is, if our toggle is 1, we'll light basically LED 1. If our toggle is 0, then we'll light LED 2. So we're going to be bouncing between LEDs. Ding dong, ding dong, ding dong, ding dong, ding dong. So it should just bounce back and forth between the LEDs. And that should be pretty much it. But the nice thing about High-Tech C, I have not played with CCSC with this yet, but with High-Tech C is that on an interrupt service routine, one thing that is very nice about High-Tech C and whatnot is that what happens is also, if you interrupt, if you've been incrementing variables and whatnot, and you interrupt right in the middle of this, and it just jumps to here and then goes back, what will happen is all your variables will be considered 0. Or they may be in some weirdo state when you enter back in. So what has to happen is actually all of your stuff has to be saved and pushed onto the stack, and then pulled back off of it and put back in when you return in. So usually you have a simple set of assembly code that does that will actually, when upon the flag, the interrupt flag, it will take and basically save the world. It saves all of your variables and everything, pushes them onto a stack, and then you jump into the service routine, and then it pushes them back. Now some of the enhanced mid-range, I think some of the enhanced mid-range ones, like the PIC 16F 1938 chips and things like that, and then any of the 18F ones, have what's called shadow registers, where you can store your variables and they do not get lost when you enter into an interrupt. But if you're working with like a 676 or something like that, it does not have those shadow registers, so you actually have to manually do it. Except the slick thing about High-Tech C is it will build that for you. It actually builds that assembly. The minute you put in a ISR, an interrupt service routine, it will automatically build that code during compile time. So when it compiles, it'll actually throw that code in there, and basically it does that for you. It saves the world for you. So that is very, very nice that it does that for you. I do not know if CCS does that or not automatically. You may have to do it manually. Well, I'll have to see when I create the video from CCS if I get around to it. I'll do that. So now we're ready to build. So we just hit our little hammer up here, and that should build it. Which looks like we've got some errors, which, you know, is to be expected. You get errors. Okay, I think I know what's wrong. I think I fixed it. Okay, well, I had to reinstall my my compiler, and I think it got messed up where it's at. But anyway, yeah, we'll throw a compile on it. In fact, here, I'll just pause the video. Let me see if I can figure this out. Yes, let me figure it out real quick. If not, then we'll just continue on. Okay, looks like I got her working now. I just had to restart it. Looks like we got an error. Option is not right. Now, sometimes you can have this. It can be tricky. You can get this all. It may have different ways. So there might be an underscore before this or something like that. So where you can look is going to be inside your high-tech C software. Pick and then the version that you're on. If you go into here, I think it's, let's see, it's under includes. If you go into here, and we're going to find, let's see, where it is. It's going to be under pick, and then you find the pick that you have. So we're a 16F, 676, where are we at? 676. If you open this with something like Notepad or something like that, you actually get the header file, and what we can search for is the option register. So it looks like it is called, yeah, see, there's your TOCSCE, all that stuff. It looks like it's just called option reg now. Instead of just option, yeah, it's called option underscore reg. So we just make that little change really fast. So option underscore, whoops, register. And now that took away our little exclamation mark. So that's another thing that's kind of cool. It does the typo thing, kind of like Word and stuff does. So now I can rebuild it. Everything should be good. Hooray! Build successful. So now we're ready to go. And then if we did have a target device, we could actually program it by clicking program, and it'll bring up the ICD3 that I have that we chose in the beginning and program this. So I may go ahead and throw this on a board and do a demo of it, just because we can, just so you guys know that it's working. And since I kind of wrote this on the fly, I kind of want to make sure that this code does work, because nothing makes me madder than when you find a bunch of code and somebody's like, oh, this is how it works. You throw it into your stuff and it doesn't work at all. So I will test this out, and I will show you guys a video of it working. And if there's any part of it that doesn't work right, I'll make sure and make that correction in the video of me demoing it. So hope you guys have enjoyed it. I'm sorry that this took a very long time, but I really wanted to get down, and I never had anyone really explain to me how to calculate it, how to really get all the bits and pieces tied up right. So I hopefully it hasn't been just a bombardation of information, but hopefully it's been very helpful for you guys. So okay guys, sorry for the length. Take care. Happy coding. Feel free to leave comments. Look forward to more videos. I should be making more. The next one will be a real-time clock. Will be the next one that we'll be doing. It shouldn't be as involved and add as many calculations, because RTCs are very nice. They do everything kind of for you. You just have to ask them what information you want from them. They just tell you. So good coding, guys. Take care, and leave comments and feedback if you want. Thank you very much.